Hello learners, welcome to week 3 of our SWAM course on Introduction to Electric and Hybrid Electric Vehicles. Today we will explore electric vehicle versus internal combustion engine vehicles. We will dwell into the technological, environmental and economic differences between these two vehicle types and their impact on the future transportation. Let us dive in and understand what drives this innovation forward. In last 2 weeks, you have gone through the different topics. In week 1, we have covered history of transportation in general and the history of electric vehicle and hybrid electric vehicle. In second week, a detailed discussion on the vehicle dynamics and followed by IC engine electric vehicle drivetrain have been discussed. Taking that discussion forward, in this lecture we will discuss about the electric vehicle and internal combustion engine vehicle and their comparison. So, before getting into the detailed discussion on electric and IC engine vehicle, let us discuss the different types of vehicle. The first category is internal combustion engine vehicle, or we call it a ICE vehicle. It is a traditional vehicles powered by petrol or diesel. It includes various fuel injection and ignition technologies for improved efficiency. The second category is battery electric vehicle powered by electric batteries with no internal combustion engine, and in another term you can call it as a engine-less vehicle. It requires charging from external power sources like electric outlet or charging stations. The third category is this: when you combine the internal combustion engine and electric vehicle together, the vehicle category that it comes out is known as hybrid electric vehicle. It combines internal combustion engine with an electric motor and a battery. The hybrid electric vehicle can be of several types. Some of them are mentioned here as series hybrid electric vehicle, parallel hybrid electric vehicle, series parallel hybrid electric vehicle and complex hybrid electric vehicle. Next category of the vehicle is plug-in hybrid vehicle, similar to hybrid vehicle but with a larger battery that can be charged through an external power source. The difference between the hybrid electric vehicle and plug-in hybrid electric vehicle in one sense can be seen in terms of in a hybrid electric vehicle, the on-board battery is charged by power taken from or power generated by internal combustion engine, whereas in a plug-in hybrid electric vehicle there is a provision to charge on-board battery from external utility grid or from external charging port. The plug-in hybrid electric vehicle offers a limited all electric range before the internal combustion engine kicks in. Another category of the vehicle is fuel cell electric vehicle. It is seen as futuristic technology for transportation system. It uses hydrogen fuel cell to generate electricity for powering electric motor. The good part of the fuel cell electric vehicle is that as long as the hydrogen fuel is supplied, it generates the electricity and that electricity is being utilized for driving the wheels of the vehicle. It emits only water as a vapor as a byproduct. Let us discuss the internal combustion engine in detail and see the different aspects associated with it, followed by the different advantages and disadvantages of internal combustion engine. So, in a simplified diagram of a internal combustion engine vehicle, you can see here it contains a pump, fuel tank, transmission line and engine. Petrol and diesel vehicle are very much similar. They both use internal combustion engine. A gasoline car typically uses a spark ignited internal combustion engine. rather than the compression ignited system used in the diesel engine vehicle. In a spark ignited system, the fuel is injected into a combustion chamber and combined with the air. The air or fuel mixture is ignited by a spark from the spark plug. Although petrol is the most common transportation fuel, there are alternative fuel options that use similar component and engine like ethanol flex based vehicle. So, this is the little detailed diagram of internal combustion engine vehicle for 4-wheel system or 4-wheel car, or you can call it a IC engine car. It has a fuel tank, internal combustion engine, mechanical transmission and the arrangement that transfers the mechanical power to different wheels of the vehicle. So, the fuel tank stores high energy density in it and it gives the IC engine. IC engine converts that high density energy into mechanical power, and that mechanical power is given to the mechanical transmission, and through that it is being transmitted to wheels of the vehicle. If we talk about the different component of the IC engine vehicle, then it starts with fuel tank. This tank stores petrol or diesel on board the vehicle until it needed by the engine. This is the sole source for storing the onboard power in a conventional IC engine vehicle, and it has a very high energy density fuel contained by either petrol or diesel. Another important component is the fuel pump. The fuel stored in a fuel tank is pumped or transferred to the engine by fuel pump, and it is being injected to the engine. Fuel line, it is a metal tube or flexible hose or a combination of these, transfers fuel from the tank to the engine's fuel injection system. Another important part of the IC engine vehicle is fuel injection system. This system introduces fuel into the engine's combustion chamber for ignition. The most important component of internal combustion engine vehicle is the engine itself. In this engine, it is a spark ignited engine. In this configuration, fuel is injected into either the intake manifold or the combustion chamber, where it is combined with the air, and the air fuel mixture is ignited by the spark from spark plug. Next important part of the IC engine vehicle is transmission. The transmission transfers mechanical power from the engine to drive the wheels of the vehicle. Now, another important and crucial component of internal combustion engine vehicle is this electronic control module, or we call it a ECM. The electronic control module controls the fuel mixture, it controls ignition timing and emission system, it monitors the operation of the vehicle, it safeguards the engine from the abuse, and it detects the troubleshoot problem if any takes place during the operation of the vehicle. Coming to the electrical component which are also available in conventional IC engine vehicle, the first one is the battery. The battery provides electricity to start the engine and power electronics control module and auxiliary accessories like lighting system, music system, power steering, power window, wiper or other electrical appliances which are on board in conventional vehicle. Another component is the exhaust system. The exhaust system channels the exhaust gas from engine out through the tailpipe. A different mechanism are designed and devised to reduce emission within the exhaust system. The major function of the exhaust system is to take the toxic gases through the process and exhale it to the environment. There has to be a process, there are the process and mechanism that takes care of and controls the emission that takes place through this exhaust system. So, these are a different component of conventional IC engine vehicle. This all components combined together ensures the smooth operation of internal combustion engine vehicle. So, the vehicle that comes out with all these component have several advantages. The advantages of internal combustion engine vehicle includes high energy density. As we know, IC engine vehicle use petrol and diesel that have a very high energy density, providing a significant amount of energy density as well as power density. So, whether you talk about the longer driving range or whether you talk about the top speed, this high energy density fuel gets burns into the internal combustion engine chamber, and it provides the amount of power required to give the thrust to the vehicle, either to take care of the highway cruising or to take care of the hill climbing or to take care of any specific requirement where huge amount of power is required. Another advantage of the internal combustion engine is that you can refuel it quickly, especially compared to a charging electric vehicle which takes longer hours. This makes them more suitable for long distance travel, and this quick refueling is also possible because the fuel station where you refill your IC engine vehicle are readily available in all the locations there we live. Another important advantage of IC engine vehicle is established infrastructure. Petrol and diesel fueling infrastructure is well established globally, making it convenient for user to find refueling station. Affordability: internal combustion engines are generally more affordable in comparison to electric vehicle, contributing to lower upfront cost for consumers. Now, driving range: internal combustion vehicle often have a longer driving range on a fuel tank or fuel compared to electric vehicle on a single charge. This makes them suitable for certain applications such as long haul transportation and long driving. Another major important advantage associated with the IC engine vehicle is matured technology. The IC engine vehicle is matured and well understood with a long history of development and improvement. So, these are some of the advantages associated with the internal combustion engine vehicle, and these are the reason for the popularity of these traditional vehicle. However, there are several disadvantages also associated with this internal combustion engine vehicle, and some of these disadvantages are environmental impact. This conventional engine burns this petrol and diesel in its internal combustion chamber, and it produces the pollutant and greenhouse gas, contributing to air pollution and severe health issues. It severely depends on the fossil fuels like petrol and diesel. Without this petrol and diesel, this vehicle cannot run and hence contribute to geopolitical and economical challenges. Any disturbance and disruption in the supply of this petrol and diesel can create problem to existing transportation system. Even in a recent days, whenever we see in a news that the fuel price is going to hike by 3 rupees or 5 rupees, we can see the huge queue on the fuel stations. But just imagine when we will get the news that we are not going to get a fuel for a day or a two or a couple of days, then what kind of chaos we will be having. So, this existing or conventional IC engine based vehicle is heavily dependent on the fossil fuels. Another is low efficiency. Internal combustion engine vehicle are less energy efficient compared to electric vehicles. They waste a significant amount of energy as heat, resulting in a lower fuel efficiency. Another disadvantages is noise and vibration. Internal IC engine can be noisy and produces vibration, leading to a less smooth and quiet driving experience compared to electric vehicles. Another disadvantage is it requires significant amount of maintenance because of the moving parts, leading to higher maintenance requirement and cost compared to electric vehicle, and fail to recover energy, and during regeneration the internal combustion engine vehicle have limited capacity to recover and reuse energy during braking or deceleration, unlike electric vehicle that can utilize regenerative braking in storing the power back to battery. Another disadvantages associated with the IC engine is emission regulation. Stringent emission regulation requires additional technologies to control and reduce harmful emissions, adding complexity to the vehicle, and IC engine is one way or other significantly contributing in global warming. So, these are some of the disadvantages associated with the internal combustion engine. One of the biggest disadvantages associated with the internal combustion engine is the efficiency. If we see the efficiency analysis of IC engine vehicle, then if the 100% of this original fuel is stored in a fuel tank when supplied to the IC engine vehicle, the IC engine converts this 100% of energy and produces only 20 to 30% of the useful energy that is being utilized for further process, and 70 to 80% of energy lost in conversion. Out of this 20 to 30% of energy, 4 to 6% are being lost as a parasitic losses. Parasitic losses are the types of losses which takes place in supplying of power to different component like cooling mechanism and other stuffs which takes power from this only. 3 to 5% of power are being lost in drivetrain process in a friction or other moving parts, and 2 to 5% auxiliary electricity, 2 to 5% of energy are being used to supply the auxiliary loads of the vehicle such as lights, music system, power window, power steering, etc. So, if you see the entire efficiency analysis of internal combustion engine vehicle, so out of 100% of energy, hardly 20 to 30% of energy is being used as a useful in a useful work, and remaining 70 to 80% is lost, and you can consider it as losses in IC engine vehicle. So, it has very poor efficiency, and this can be taken and considered as one of the biggest disadvantages of internal combustion engine vehicle. Due to the limitations associated with the conventional IC engine vehicle that we have recently discussed, electric vehicles are seen as the promising and sustainable alternative for the future transportation system. We have discussed in detail the environmental, social and economical impact of this electric vehicle in first week, second lecture. Let us discuss the basic architecture and operation along with the working of electric vehicles. So, this diagram shows the simple architecture of electric vehicle, or in another term it is called battery electric vehicle. It has a plug to charge on-board battery and a rechargeable battery along with electric motor. So, the plug gives power to rechargeable battery, and rechargeable battery delivers power to electric motor through power controller unit. This is more detailed diagram of electric vehicle. So, here you can see high energy battery pack is connected with the power electronics converter, and power electronics converter is connected with the electric motor, and the electric motor drives the wheels of the electric vehicle. So, here the power electronics converter creates the compatibility between the battery pack and electric motor. Battery pack has different sets of power output, and motor requires different sets of input power. So, this power electronics converter creates the compatibility of power between the battery pack and electric motor, and that is how this electric vehicle gets on road and it gets propelled. So, if we talk about the different component of electric vehicle, then Some of the major component of electric vehicle can be seen as traction battery pack, which stores electricity for use by the electric traction motor. The power stored in this traction battery pack is sole responsible for driving performance of the electric vehicle by electric motor. It also has an auxiliary battery. This auxiliary battery is responsible to supply the electrical power to the ancillary loads or auxiliary loads of electric vehicle, like lighting and power steering, power window and music system, etc. It has a power electronics controller. It manages the flow of electrical energy delivered by the traction battery, controlling the speed of the electric traction motor and the torque it produces. So, it creates the compatibility between the battery, onboard battery and electric motor in a way that the electric motor should meet out the demanded torque and speed requirement of the vehicle. It has electric traction motor. It using power from the traction battery pack, the motor drives the vehicle's wheel. Some vehicles use motor generators that performs both the drive and regeneration function. It can act as a motor when power is supplied, and at the same time it can act as a generator when it is rotated by, when the shaft of the machine is rotated by the inertia or momentum of the vehicle. So, it can act as a motor or it can act as a generator. Another important component of electric vehicle is DC to DC converter. This device converts higher voltage DC power from the traction battery pack to lower voltage DC power needed to run vehicles accessories and to recharge the auxiliary batteries. Another important component is a charging port. The charging port allows the vehicle to connect to an external power supply in order to charge the traction battery pack. Another important component is an onboard charger. Takes the incoming AC electricity supplied via charging port and converts it into a DC power for charging the traction battery. It also communicates with the charging equipment and monitors battery characteristics such as voltage, current, temperature and state of charge. In short, we call it a SOC while charging the onboard battery pack. Another important is the transmission. In electric vehicle, it is mostly a electrical transmission. The transmission mechanism transfers mechanical power from the electric traction motor to drive the wheel. It can be a electrical transmission as well as can be a mechanical transmission. Another important component of the electric vehicle is the thermal management system or a cooling system. This system maintains a proper operating temperature range of the engine, electric motor, power electronics converter and other components. So, these are the major component of electric vehicle. Let us have a discussion on different advantages associated with the electric vehicles. One of the most important advantage of electric vehicle is the zero emission. Electric vehicle produces zero tailpipe emission, contributing to reduced air pollution and greenhouse gas emission, which helps combat the climate change. Another advantage is energy efficiency. Electric motors are highly efficient in converting electrical energy from the grid to power the vehicle, making electric vehicle more energy efficient than internal combustion engine vehicle. Another important advantage is lower operating cost. Electric vehicles generally have lower operating cost compared to traditional vehicle, as electricity is often cheaper than petrol and maintenance costs are typically lower due to fewer moving parts. Another biggest advantage associated with electric vehicle is independence from petrol and diesel, though it depends on a fossil fuel up to certain extent, but it is in one sense free from requirement of petrol and diesel, which helps promoting energy diversity and energy security. Another important advantage is quiet operation. Electric vehicles are quieter than traditional vehicle, contributing to reduced noise pollution in urban areas. And incentives and tax credit. Many governments offering incentives and tax credit to encourage the adoption of electric vehicle, making them more financial attractive for consumers. In India, we are getting good incentives under FAME scheme of Government of India. We are getting good subsidies from central government as well as state governments. The amount of subsidy varies from state to state. So, these are some of the important advantages associated with the electric vehicle. However, there are several disadvantages as well associated with this electric vehicle, and one of the most important disadvantage is the battery technology. The battery is seen as the bottleneck of this vehicular electrification. Because of that, it offers limited driving range. Some electric vehicle may have limited driving range on a single charge compared to conventional IC engine vehicle on a full tank of petrol, although this is improving with advancement in battery technology. Another disadvantages associated with the electric vehicle is lack of charging station infrastructure. The availability and accessibility of charging infrastructure can be limitation, especially in certain region, making it challenging for some user to charge their vehicle conveniently. Another is longer charging time. While charging technology is improving, the time it takes to charge electric vehicle is little longer than refueling a traditional vehicle with petrol or diesel. It has high upfront cost. The initial cost of electric vehicle, particularly the cost of the battery, can be higher than that of the traditional vehicle. However, this is gradually decreasing as technology is getting advanced over a period of time. Another disadvantage is battery degradation. The performance of electric vehicle batteries can degrade over a time, affecting the vehicle's driving range. Battery replacement cost can be significant, although ongoing research aims to address these issues amicably. Another disadvantage with electric vehicle is limited model and varieties. While the number of electric vehicle model is increasing, there may still be fewer options compared to traditional vehicle, limiting choices for consumer. At least in a country like India, at present we are having a very limited option for electric four-wheeler segment. However, we are getting good amount of options and range for two-wheeler electric vehicles. Another thing is the resource intensive battery production. The production of electric vehicle battery requires certain rare and potentially environmentally impactful material, raising concern about the sustainability of battery manufacturing. Challenges in recycling and disposal of electric vehicle battery presents challenges due to the complex composition of lithium ion battery and the need for proper recycling infrastructure. So, these are some of the disadvantages associated with the electric vehicle. However, the electric vehicle, one of the biggest advantage that comes with the electric vehicle is its efficiency. So, let us see the efficiency analysis of electric vehicle. If 100% of energy is supplied to electric vehicle, its 80% of energy is being converted into useful work done. Only 15 to 20% are lost in drivetrain losses, 3% energy are being lost in power steering or cooling mechanism or similar stuffs, and 4% of energies are being used or lost, you can say, in supplying the electrical power to auxiliary component of electric vehicle. So, in totality, if you see, out of 100%, at least 80% of energy can be supplied to the wheels of the vehicle for production of the tractive force or movement of the vehicle, and 20% are lost, just unlike the ICE engine vehicle, where out of 100% of energy, 20 to 30% are being converted into useful work done, whereas 70 to 80% is lost. In electric vehicle, out of 100%, 80% is being converted into useful work done. However, the significance of energy, let's say for 22% or 20, these numbers and these figures are tentative. It may vary from vehicle model and associated model to model and along with the associated technology, and the significant amount of energy can be recovered during regenerative braking and deceleration. So, let us compare the electric vehicle and IC engine vehicle in a specific terms. Before we can make a comparison of electric car to IC engine car, we need a common way to measure energy consumption. For IC engine vehicle, we use liter per 100 kilometer, and for electric vehicle we use kilowatt hour for 100 kilometer. To keep everything in kilowatt hour, 1 liter of petrol can be equated to 9.5 kilowatt hour. Okay. So, if we have to travel 100 kilometer, how much energy is required in case of electric vehicle and how much energy is required in case of internal combustion engine? From this figure, this is a tentative numbers. It may change on a case to case basis or analysis basis considering the different parameters and component. So, as illustrated in the chart, petrol car need almost 5 times more energy than electric cars to travel the same distance. Electric vehicles are very efficient, 80 to 85% of the energy is used to move forward and only about 50 to 20% is lost to heat and friction. Whereas, the petrol cars on the other hand use only 20 to 30% of the available energy to drive the wheels, and 70 to 80% is wasted as heat and friction in the engine and gear box. So, that is all for the first lecture of week 3. Thank you all for participating in today's lecture on electric vehicle versus IC engine vehicle. I hope you got the good idea about the electric vehicle, associated advantage, disadvantages, and IC engine vehicle and its associated advantages and disadvantage. We explored the key differences and highlighting their roles in evolving landscape of transportation. I hope this session has provided you with valuable insights and a deeper understanding of the future of mobility. Please review the lecture materials and feel free to post any question or comments on the forum. Looking forward to seeing you in our next session. Have a great time, keep learning. Thank you.